Good evening, Algebra 2 students. Today we're going to learn exponential models. Now, before we begin, I would like to point out that I will be helping you with the homework. Now, if you follow this video, you do have an advantage because I will be giving out answers for the homework assignment that is due on Schoology. Now, what I don't want to do is call out all those people who have already done the assignments without getting any knowledge, right? So there's probably a lot of reasons for that. You probably already know it, or you probably researched it. I don't want to know, but hopefully this video will help you out. So very first thing that I want you to write down is, well, this is the lesson for today, right? In your lecture notes, it begins with exponential models. Now, the very first equation that you're going to see is exponential growth model. Similarly to what we saw before with y is equal to a times b to the power of x, right? In this form, the exponential function. Now b, the base, is going to take a new form, right? So here in the model, we see that the base actually takes the form of 1 plus r. Now, this right here makes sense because whatever r is going to be, whether it's a big number or a small number, right, like 0.1, or a big number like 2, 3, 4, 5, right, any big number, you already knew that if the base was greater than 1, then we're going to have a growth model, right? So from the same concept, if you knew that if b, the base, was between 0 and 1, you knew you were going to have decay. So these are simply variations of what we previously have. Now another variation is that instead of having an x, now we have a t. So let's try to understand each of these variables, right? Let's start off with the y. The y is the amount, let me go ahead and read for you. The amount y of such a quantity, right? So what are quantities? What are some examples of quantities? We see, for example, the value of a car, population growth, things like that, of that sorts, that require you to have a model for it, right? So t is pretty straightforward. T in this case is going to be years. A is going to be the initial amount. So say you have a population growth, well, obviously you got to start somewhere, right? So if you're starting the year, say 2010, we're currently in 2020, which is a 10-year period where we're going to see a new population growth. So actually, this is a very good way to start the year, right? So knowing how to model exponential growth. But anyways, yeah, A is the initial amount where you start off with, and R is going to be the percentage increase or decrease, in this case, written as a decimal. So I may ask you in the homework to tell me R in decimal, or I may ask you to tell me R in percentage. I will let you know once we get there. So exactly what they were saying, the quantity 1 plus R is the growth factor. We know that 1 plus R is going to be greater than 1, so it's a growth factor, and 1 minus R is less than 1, but also greater than 0, therefore decay factor. So let's jump right into the real life example. So say you have the value of car Y in thousands of dollars. So a lot of you know, and you can actually ask your parents, so when you've bought a new car, the value of the car actually decreases the moment that you exit the dealership, right? So this is a model, a really good example of a model of what the value of your car is going to be over time, over the years, right? So this the value of your car can be approximated by the model y equals 25 times 0.85 to the power of t, where t is the number of years since the car was new. So the very first question to ask you is, tell whether the model represents exponential growth or decay. So first and foremost, is this number greater than 1? No, therefore it is not growth. Is it between 0 and 1? Yes, it is. Therefore the answer to that is exponential decay. Again, you will see that as one of the questions. This model represents exponential decay, right? So let's go back to the preview. I'm not going to keep going back and forth because you can pretty much just pause the video and get a lot of the answers for some of the questions. Part B says identify the annual percentage increase or decrease in the value of the car. So what you're going to be doing is you're going to compare this equation that is given to you to the exponential decay function, right? Which is the model, which is located above, right? So here we can tell right away that our A value is 25. We can tell that the 1 minus r is going to be equal to 0.85. So what you got to do is actually set that equation up. 1 minus r is equal to 0.85. And in that moment, you have to solve for r. You can do that by adding r to both sides and subtracting 0.85, or you can subtract 1 on both sides, divide by -1. Do what you got to do, but solve for r. Once you solve for r, you should get 0.15. Now 0.15 does translate to 15%. Now, a good hack, a good way to do this real quick is that this decimal, you move it over 1, 2, twice to the right to get your percentage, right? So in case you do have the percentage and you want to know the decimal, you start here where the percentage symbol is and you move to the left twice, 1, 2, and you get back your decimal. So that's a good way to convert decimals into percentage back and forth. Now, part C says estimate when the value of the car will be 8,000. So here you're not plugging in 8,000 into T. Well, that makes sense, right? Because T is what? T is years. So what is this value? Here we have money. And which one of these variables reminds you of money? Well, if we read carefully, we learn that Y is in thousands. So since this is already in thousands, we find out that Y is actually equal to 8, right? So you're not putting 8,000 for Y, you're putting 8 because Y is a value in thousands. So if you do something like this, what I'm going to ask you to do from here on in is going to use decimals, right? Because you're going to need a graphing calculator. So let's go ahead and plug in this equation into decimals. So here on decimals, we're going to go ahead and see this website, decimals. Go ahead and start graphing. Y equals 25 parentheses 0.85 close parentheses to the power of t, right? So again, you're here and you don't really see anything. A lot of you can see on the right side, right? So what you got to do is just zoom out a little bit, but to find that intersection, right, you're finding out when Y equals 8. So this is a good way to find that point of intersection. Again, what you can do, you can click on any one of these points and they'll tell you that point of intersection. So that point of intersection is when x is equal to, in this case t, right? So when t is equal to 7.011. So let's go back to our example, and we see here that when Y is equal to 8,000, that it takes roughly about 7 years. Now, the reason why this solution says something different is because they assume that you actually have a graphing calculator, like an actual handheld device, right? And what they actually want you to do is they want you to use the trace feature. But because here, the way I showed you, the way I modeled it to you to point of intersections, is all you got to do is just plug in that Y is equal to 8, and then you will find about how many years it takes. So you notice that on the answer on decimals it had 7.011, and well, the 0.11 is part of the year, so I don't know how long that is in terms of months. I don't know how long that is in terms of days. So what they want you to estimate is that t is equal to 7. So that is it for today. This video is getting kind of long. I will have a second video for helping you how to write exponential models.